Energy feeds a system based on more consumption, more travel, more stimulation. But what happens when we all just stop? Will a day at the office ever be worth the long, hard commute? Will we be able to justify the weekend city break or overnight business trip? In a world changed by the COVID-19 pandemic, DNVGL believes it is more important than ever to understand our energy future. This is that story. The economic and behavioral impact of COVID-19 has reduced the amount of energy required by humanity. In 2050, the world will use 8% less energy than previously forecasted. COVID-19 has hastened decarbonization milestones. Oil demand is unlikely to recover to previous levels, and 2019 will go down as the year of peak CO2 emissions, 5 years earlier than the pre-pandemic forecast. Yet, we are still nowhere near on course to limit global warming to sustainable levels. We need to repeat this year's extraordinary emission reduction every year through to 2050 to reach the ambitions of the Paris Climate Accord. But there is hope in the extraordinary nature of the energy transition. In the space of a generation, renewables will gain parity with fossil fuels in the energy mix. 2032 is the year of peak energy, the first time in post-industrial times that humanity will start using less energy despite the global economy growing. Electrification is spreading at breathtaking speed. 41% of final energy demand will be met by electricity by mid-century, double today's level. It is perhaps the electric car that best demonstrates how policy and technology can combine to spectacular effect. DNVGL forecasts that by 2032, half of new cars sold will be electric. A tremendous turnaround for a sector previously considered difficult to decarbonize. But other industries must follow. Natural gas will be our largest single energy source for decades to come, yet only 13% will be decarbonized by mid-century. Hydrogen holds enormous potential for difficult to decarbonize sectors, but it needs a significant push from policy to scale. We must use the technology available to us to transition faster.
So hello and welcome to this panel, the new strategic priorities for energy industry in a post-COVID environment. Then thank you very much for joining. I'm Liv Hovem. I'm the CEO of Oil and Gas in DNVGL. DNVGL is a technical assurance and advisory company with 12,000 employees, and we're headquartered out of Norway, and with many operations in many countries globally. And since today I feel like I'm in Italy, I can mention that we also have a significant operation there in Milano mainly. So today with me in my panel, I have an impressive panel. We have Robert Armstrong, who is the director of the MIT's Energy Initiative and Chevron Professor of Chemical Engineering. I have Fabrizio Buta, who is the Global Strategy, Commercial and Tendering Director at ENC Onshore Division in Saipem. And last but not least, I have Michele Stangarone, who is President Novione Pignone and Vice President of Baker Hughes Turbo Machinery and Process Solutions in Europe, Russia, and Sub-Saharan Africa. So welcome to all of you. So today we have a wide frame for our discussion, I think, and it's about the situation we have today, where we have COVID effects, we have a downturn in the oil and gas sector, we have growth of renewables, and we have emission reduction targets to meet climate goals. And really all this is blended together and requires that the energy sector and the energy industry must revisit their strategic priorities to remain relevant for the future. The video we just saw is a very, very quick summary of a report that we just launched in the NVGL about energy transition outlook towards 2050. Really the main takeaway from that report is that we will see a tremendous energy shift towards the next generation. But given, despite of all the positive development in the renewable sector, we are not moving fast enough in order to decarbonize the energy system in such a way that we will meet the emission targets set by the Paris Agreement. And this is some of the things that we will discuss today. So what we will do is that I will give each panelist the time to do some introductory remarks. And following that, we will engage in a dialogue, and we will also take questions from the audience through the Q&A facility. So with that, I wish to introduce the first speaker, Robert Armstrong. He is the director of the Energy Institute of MIT and a professor of chemical engineering, as mentioned. He has been a member of the MIT faculty since 1973. Armstrong has served as head of department of chemical engineering from 1996 to 2007, and he has directed the Energy Institute since 2013, after serving as the organization's deputy director from 2007 to 2013. And his research is focused on the pathways to a low carbon energy future. And Bob, the word is yours. I'm looking very much forward to your presentation.
Good. Thank you very much for the kind introduction, and thank you for having me, or thank the organizers for having me on the panel. I feel honored to be with this distinguished group to reflect on where we're going in reaching a low carbon future. So the video we just saw was certainly very encouraging and an optimistic view of how we might get to net zero emissions as we go forward. And I thought I would just show a couple of slides looking at emissions trajectories globally and in different regions of the world to make a few points about some of the challenges here. So what you see in this first slide is a look, and let me acknowledge Sergei Paltsev in particular, who's a senior researcher at the MIT Energy Initiative and the Joint Program at MIT. And this is from their global economic and climate model called EPA. So this looks at global CO2 emissions out to 2100 for two trajectories. One is for a 2-degree future, so staying below 2 degrees by 2100. And the second, the gold curve, is 1.5 degrees C. What you'll notice is that consistent with the video you just saw, we have to peak emissions in the very near future and decrease those out to end of century. What's particularly important to take away from this slide is that negative emissions for an economically efficient solution to meeting net zero, emissions need to go negative by mid-century or so. This is consistent with a number of reports that have been published back in 2018-19, the national academies in the US, as well as other places, put out reports speaking of negative emissions on the order of negative 10 gigatons of CO2 a year in order to be able to hit the aggressive climate targets we have. The next slide shows how that's distributed around the world and looks at, on the left-hand side, the 2-degree scenario, and on the right side, 1.5-degree scenario. The different sets of bars correspond to different regions, or in a few cases, specific countries. The bars are 5-year increments, which is the time step of this integrated assessment model, EPA. So it looks at emissions in those 5-year time steps. And you can see the developed countries, the US, EU, Australia, Japan, and so on, are projected to need negative emissions around mid-century in order to hit these, in order for the world to hit net zero targets. The other G20 countries do not necessarily, and that's the other G20 countries, but excluding China and India. Those are pulled out specifically because they're such large economies and such large emitters. China, you see, is the largest emitter today, and that needs to decrease almost monotonically. It'll peak 2030 or so. That's their confirmed commitment as of this past week. India needs to go negative, and the rest of the world, think sub-Saharan Africa and slowly developing countries around the world, will need to go substantially negative by end of century. And notice that they don't peak CO2 emissions until later, 2050 or so. In a 1.5-degree scenario, all those regions have to go negative in order for us to hit climate targets. That's the main takeaway I want to leave you from that slide. The last slide I'm going to show is important because it reflects carbon prices to get there. So I'm going to assume that whatever the policy is, this gets converted into some equivalent price on carbon, so that we can see just what it costs the economy in order to achieve these goals. So this CO2 price, we put business as usual there. That's the baseline at the very bottom. You don't see any price on carbon. But to hit a 2-degree scenario, or either with or without negative emissions technologies. So the purple curve is the one without negative emissions, and green is with negative emissions. And negative emissions here is exemplified by bioenergy plus CCS. It's not what we need to end up with, but that's the placeholder we put in there. So assume that you grow energy crops, you harvest those, you burn them, you capture the CO2, and you sequester it. So a negative emissions technology. In the case that we don't have a negative emissions technology that's allowed, what you see is the dotted purple curve and the solid purple curve for 1.5 and 2-degree scenarios. And you see carbon prices get quite large as you approach the final goal of net carbon, of net zero emissions by end of century. So thousands of dollars per ton of CO2. On the other hand, if you allow for negative emissions, so the solid and dotted green curves with the bioenergy and CCS technology allowed, you approach a constant value of CO2 price, which is set by the price of the technology, basically. So if we end up with a better option, a cheaper option for negative emissions, then that price goes down. If we don't do quite as well as that, price goes up. But that's about a $240 a ton price on CO2. It's a global price on CO2. So that's a really, really big challenge to achieve, particularly in developing countries around the world. So let me then just, that's all I wanted to do with the slides. I wanted to talk a little bit about what it takes to get there. And as you can see just from those slides, we're going to need to bring together science, think new technologies for producing zero carbon energy, ways to innovate around our existing system, and we need to bring policy to bear. How do we put the right regulatory frameworks in place, the right pricing structures if we use a price on carbon? What's the way to frame those policy initiatives to get us where we need to go? So I'd like to talk about those, but with an emphasis in my comments on the science, technology, and innovation pieces, I think consistent with the theme of this particular session. And I like that because this is a theme at the MIT Energy Initiative. Our research portfolio has taken a three-pronged approach since we began back around 2007. And our three prongs are innovation. How do we make today's systems better? As pointed out in the video, we'll be using natural gas, for example, for decades to come. How can we minimize CO2 impact from our existing technologies? Transformative technologies. So what are the really new technologies that can help us get to where we need to go to reach our climate goals? And then thirdly is integration. So how do you put all the pieces together? Because at the end of the day, consumers don't care particularly about a specific technology, they care about the services that the energy system delivers. Think flipping the light switch and you want to make sure the lights come on, not stay dark. So that's what we're after, figuring out how to leverage those three areas to meet societal needs. So in innovation, I'll focus on one that was prominent in the couple of slides I showed, which is CCUS, right? That's clearly going to be an important area for us. And it's an important area where the oil and gas sector, I think, has to play a leading role. Sequestration requires the kind of capabilities from the oil and gas sector for characterization of subsurface, for understanding how you can inject subsurface, how you can avoid induced seismicity, where are the locations where you can sequester, what kind of long-term sequestration are you looking for? Are you looking for solubility or capillary trapping mechanisms, mineralization? You're going to do this offshore or onshore? So I think there are a lot of possibilities there, and I think we're starting to explore those. I think Northern Lights project with Equinor, Total, and BP, I think is an interesting example of looking at how we might sequester CO2 away from population centers where people live. So use the North Sea, for example. Capture technologies are important. How can we lower those costs, even lower than what I showed with those BECS estimates? New power cycles are possible. The alum cycle, the supercritical CO2 cycle is an interesting cycle. There are a number of new startups, actually, which is quite fascinating in a business the scale of CCUS. Global Thermostat, Climeworks, Verdox, are all interesting technologies and companies that promise very low cost direct air capture. Beyond direct air capture, looking at direct ocean capture, we also have a problem trying to remove CO2 from the oceans. If we can do that, that can help us speed up our equilibration of the climate system. Adapting nuclear to new modes. There's interesting research on the nuclear battery. So small 10 megawatt nuclear power devices that are fail safe, but can provide the kind of firming up you need in parts of the electricity system and the power system that have heavy intermittent renewable resources. Those are some quick examples on the innovation side. Under transformation, there I think a really interesting case study is fusion. I think none of us thought 5 years ago fusion was anywhere near in our future. There are north of 20 startups around the world now in fusion. There is an industry group of fusion startup companies, which again we wouldn't have thought possible 5 years ago. There are investments from large oil and gas companies in these fusion companies, which is fascinating. What's particularly interesting about the startup fusion companies is that they have different approaches to new technology approaches to bring the decades of science, fundamental science that's been government sponsored, bring that to fruition on much shorter time scales and much smaller physical scales than say the large international the ITER project. Low carbon fuels generally are an interesting area of transformative work. Again, that's an area where I think oil and gas companies will likely play in a large way. We and others have a lot of work on solar fuels. So think circular economy where you use some external energy input like solar or wind to put energy back in to reduce CO2 back to something you can stick hydrogen on and provide the energy to split water to get the hydrogen. Biofuels, I think, will play in certain regions around the world where there are good bioresources. Hydrogen is no doubt a vector that's going to be very important in reaching our climate goals. And you saw that in the movie. And I think there's a lot of interesting infrastructure questions that need to be addressed to make a number of those successful. And again, I think oil and gas is particularly well suited for those large infrastructure challenges. And then I'll end with a few comments about the integration. I want to respect the time here for all the other panelists. So with integration, I think one of the really interesting challenges is as we develop these exciting new technologies in solar or fusion or hydrogen, how do those fit together, work together to provide those services that we need? How do those differ from one part of a country or region? So different parts of the EU have different resources, different energy infrastructure. Same's true in the US and other parts of the world. How do you take advantage of those local resources or regional resources and infrastructure and put together the technology pieces that allow the system to minimize CO2 emissions and cost to the consumer? One of the things we've done at MIT in the last couple of years is develop a system a tool we call Sesame. It's the Sustainable Energy Systems Analysis and Modeling Environment. And it divides all the energy system processes into a set of 6 different stages. From at the early stage, the energy source that you harvest, whether it's solar or oil or gas, all the way to the end use application. And a user can pick something out of those different stages. What do you harvest? How do you move it around? How do you process it? How do you get it to the consumer? And what is the final, and add up emissions contributions from all of those. And with that, you can understand individual pathways, but integrated, you can understand the energy system in a country, in a state like California, for example, or the New England states, or a region in the EU. So I have done better than my 10 minutes. So let me stop there, and we'll pick up other topics during the conversation. So thank you very much.
Great, Bob. Thank you. There is so many questions to ask, but I think I will leave it for afterwards. And now turn to Fabrizio, Mr. Botta. He sits in Milan, I think. So we're moving from Boston to Milano. Mr. Botta, he earned his master's degrees in mechanical engineering from the University of Palermo in 2006. He also has a master's in renewable energies and an MBA from Politecnico of Milan also. He began his career. He began his career with Edison and has worked with various technologies, such as within fossil fuels, with wind, solar, and with biomass power plants. In 2010, he moved to Saipem. He has had a vast differences of managerial positions, including managing operations in UAE and Kuwait. And now he is in his current position as the Global Strategy Commercial Tendering Director, as I mentioned. So Fabrizio, the word is yours.
Thank you very much, Liv, and good afternoon to everybody. Can you see my screen? Is it working?
Yes. Okay,
perfect. So let me first thank all the organizer for inviting me in such an important event. For me, it's the first time, and it's really a pleasure to talk with such a level of participants and speakers. I hope I can contribute positively on this kind of discussion, and I would like to bring the point of view of a contractor and oilfield services company like Saipem, which is really well diversified in 5 main divisions. Saipem is an international oilfield service company working in drilling onshore and offshore, engineering and construction onshore and offshore, and early engineering services through our newly created division, which is called Excite. Today, I'm going to start by giving you some, I would say, tips about the impact of the COVID-19 on our industry, which I think it's really important to understand how we are setting up our strategic priorities. Then we would go with the strategic priorities that we have identified to finalize this kind of speech with the vision that we have related to the overall energy industry. So first of all, the COVID-19 pandemic for sure affected the global economy at large. And for our industry, that means 2 main things. Together with oil and price volatility, this constitutes a tremendous acceleration for the energy transition that we are living. So this is for sure. The COVID is accelerating the energy transition. We can see in the slide the big impact on the consumption, on the energy demand during the lockdown period, reaching even 30% in case of fully lockdown. The projection of the EIA related to the end of 2020 in terms of reduction of consumption are really impressive. And as we can see, only renewables for their nature are expected to grow with the gas, which is more resilient than coal, oil, and other sources. Why all this kind of impact? First of all, because there is 1 main difference of the COVID-19 with respect to other crises in the past happened in the oil and gas industry. And this is the nature of the causes itself. COVID-19 and cultural changes are characterizing the current situation, while actually the previous crisis was most based on a financial crisis from one side or geopolitical reasons, giving instability to the oil prices. This time we see a different situation. So what we see, it's really a structural change in the overall energy industry, and we have to cope with that. We have to find the way to still play a leading role in the industry in such a different environment. I want to be clear on something. I think COVID is just an accelerator, but the energy transition is something that is ongoing since years and will be going for years ahead. So this is not something that we will solve by taking certain decision now. It's a really complex path that we need to take in the best way, and to do that, we need to make decision on the business model that we want to develop. Why the energy transition is going for years? First of all, the energy routes have been drastically changed over the years from west to east. And one of the main contributions was deriving from the shale and from the LNG infrastructures that also changed the geopolitical equilibrium. The situation now, it's really even, I would say, complicated about the impact of the new technologies, which is huge. industrial improvement and exploitation and full development of the renewable value chain is giving a powerful, I would say, force to the entire energy industry going in a specific direction. Even financial institutions, manufacturers, clients, there was a huge development in the last, I would say, 10 years. So what is happening to our energy industry? Basically, for sure, there will be a reduction of the oil demand, and we see this potential reduction of the oil demand to become probably as a new norm. And the coronavirus will also accelerate the role of the natural gas in the value chain. What is really important to consider, in my opinion, is related to the fundamentals of the industry. So let's look about the global, I would say, balance between demand and supply. Even in the most aggressive scenarios that we can see now, recently there was a BP with this energy outlook for 2020. The role of oil and gas in the industry, even in the most aggressive scenario for the renewables and for the overall, I would say, decarbonization of the industries, is reaching something in the range of 30%. 30% coupled with an increase of demand, which the world is in a way going to experience. This is something that will raise important questions about the level of investment in the oil and gas. So the oil and gas, together with, let's say, the phenomenon of the oil and gas field depletion, still requires investment. The oil and gas industry has to think about that, because the more we are waiting, the more the industry delays such an investment, the more the risk of an imbalance between supply and demand will arise. And this risk, I know that this is not, let's say, fashionable in this period of time, but this kind of risk is a risk for the entire energy system, also for the renewables, also for the decarbonization, because we need to stabilize the discontinuous production of renewables. So, all in all, it is important to note that transition means a movement, a gradual movement from one state to another state. So it requires time, and we need to think with an holistic view about this transition. So if we go to the strategic priorities, before saying which are our strategic priorities, I don't know if you can still see my slide on the screen. Okay. So I think there is one important consideration we have to make, and this consideration relies on one word, which is really important, and is uncertainty. So uncertainty is characterizing our industry now. I don't think it's only a matter related to our industry, but uncertainty makes more difficult the definition of strategic lines for a company like ours, but also for the oil and gas companies, and also from supplier, manufacturer, for the whole supply chain. The energy industry we knew since years is changing. So any kind of consideration we could make considering the lesson learned on the past, now that could lead us to the wrong conclusion. We could be dramatically wrong if we think about what happened in the past and we reflect it on what can happen in the future. The pace of transition is strongly increasing. So we are in a situation in which also oil and gas companies do not know the returns that can arise from these new business models related to the energy transition. And this is something which is really important to consider. And another factor which is giving a lot of uncertainty is, let's say, related to policies, decision-making process, governmental decision-making process. Government do not have the same, I would say, lead time to take decision than what the industry needs. While the industry need to take some decision. So we are in a situation in which we should define where to go, having something which is really big as a question mark, which is behind our shoulders. And this is something which is really important. So all in all, in such a level of uncertainty that we have in our scenario, we must identify a Northern Star. So at Saipem, this Northern Star that we have been identifying is strongly connected with the decarbonization. So for us, what is giving us a vision in which we can structure our strategic line is the concept of decarbonization. Decarbonization which is not only related to the oil and gas industry, but it's a more holistic approach to the entire energy system. Which are our strategic priorities? So 4 main strategic priorities. First of all, natural gas. Natural gas is a pillar of our strategy because the prospect reflects something which is connected with the, let's say, superior air quality, which has the natural gas with respect to other fuel. So natural gas is needed, LNG is needed, but we want to do more. We are thinking about solution which can go in a sort of greening area for the natural gas itself, because we can do that by blending natural gas with hydrogen. We can do that by combining natural gas into the reforming for the production of the hydrogen together with CCUS. So this is something that we are doing in terms of hybridization of our value chain. The second pillar of the strategic line, for sure, are renewables. Renewables are growing with a CAGR, which is tremendous. So we cannot forget renewables, even if, let's say, the profitability connected to renewables with respect to the previous oil and gas industries is different, but we cannot forget that. And we have in our DNA at Saipem the competencies, the asset, we have the resources that can allow different value proposition for our client, especially, as you can see, in the field of offshore wind, solar, and biomass. The third pillar is the hydrogen supply chain. We want to play a leading role in the hydrogen supply chain. Why we want to do that? Because we can rely on significant experiences according to our DNA, according to our current value proposition. We are working on refinery, we are working on petrochemical. The way we treat the process connected with the hydrogen, it's something that we have been doing since years. It's not something new. So the way to develop a proper strategy on the hydrogen value chain is a key, and what we see is the need to identify the appropriate business model. In terms of the hydrogen, we see that basically we believe blue hydrogen will be the one enabling the green hydrogen. We must first start with blue hydrogen because of the competitiveness, because of the constraint related to the green hydrogen. But the green hydrogen will start immediately after, in parallel with the development of certain technologies and processes that will allow it to go ahead very strong. And finally, what we see is the role, as I appreciate before let's say the introduction of my colleague, about the CCUS. So we see this as a tremendous, is of a tremendous importance, the role of the CCUS, for one simple reason. CCUS, in light of this kind of net zero approach, is the enabler of the net zero approach. Without CCUS, we cannot do that. At Saipem, we identified this kind of strategic priorities a few years ago, by developing a strategy on the technology itself. We went to acquire new technologies in Canada, CO2 solutions, which is a carbon capture technologies, specifically related to this field. But we see for the CCUS a more integrated role. And this is why I'm going to show my last slide, because I think I will take other 2 minutes and then I will finish to recover some time. So this is basically the vision we have in terms of decarbonization. The vision we have is a fully integrated approach on the decarbonization that we see oil and gas industry together with energy intensive industry. We see a fully integrated approach because each part of our value chain includes some need of CO2, but at the same time includes emission of CO2. So what we can do, we can go with a sort of geographical approach by selecting the industries close one to each other, by capturing CO2, by considering the implementation of the combined use of CO2 with hydrogen and with steam reforming for the production of blue hydrogen. We can decarbonize the oil and gas industry. We can give further value to the oil and gas industry. We can give a different value proposition. And just talking about Italy, for example, that is suffering a little bit a sort of needs of more strength in its industrial role. we need to reinforce this kind of vision with the oil and gas industry, but also in the energy intensive industry. And we can do that by deploying this kind of overall vision of the decarbonization. So we can go with power plants, we can go in the cement industry, we can go with the steel factories, capturing CO2, putting CO2 in a very strong and important overall CO2 capture line and transportation line to arrive to a CO2 storage. So this is the vision that we have, and this vision is based on one important consideration. The industry is here. It's not like other field. The industry of the CO2 is ready since years. There is everything there to be completed. We can create a real industrial role for the industry. We can go really far away, and we can export this model in the world. So this is how we see really the decarbonization and the vision of the future for the oil and gas and for the entire energy industry.
Wow, thank you. Thank you very much, Fabrizio.
You're welcome.
So now we will move from Milano to Florence, and I wish to introduce Michele Stangarone. Michele started his career in Opinione Turbo Machinery Engineering in Florence in 1985. In 1990, he moved to Houston as a regional sales manager. And in 2000, he returned to Italy, where he headed the GE Oil and Gas Downstream Business Unit. In 2016, Michele moved to London and was appointed President and CEO for the GE Oil and Gas Europe region. And in April 2018, he was appointed Chairman for Opinione. And in January 2019, he was promoted to his current leadership role, where he oversees all the activities for the 3 regions of Baker Hughes and continues his role as chairman of Opinione. And Michele, he holds a degree in nuclear energy from nuclear engineering from the University of Pisa. So welcome, Michele, and the word is yours.
Thank you. Thank you, Liv. I hope that everyone can hear me well. It's great to be speaking to you at this REM webinar. I would like to thank particularly the organizer for their work in bringing this event online, on an online format, which is just another way our industry is embracing change in an incredible year. I would like to bring the perspective of a company that makes products and solutions. We are part of Baker Hughes, an energy technology company that provides solutions for the energy and industrial customers worldwide. We have what we call an integrated offering that goes through 4 companies: oilfield services, oilfield equipment, my specialty, which is turbo machinery and process solutions, and digital solutions. We operate in 120 countries, 60,000 employees. We basically design, manufacture, deliver leading technologies for our customers that are helping move the energy resources for the place where they're produced to the place where they're needed. The turbo machinery process solution is a division headquartered here in Florence, centered in Italy around the Nuovo Opinione legal entity. We have overall more than 9,000 people worldwide, of which 1,000 people are field service engineers. You can imagine the challenge of 1,000 people in a COVID situation. And we have probably the largest portfolio of rotating equipment, process flow, transmission technology, life cycle services. We span on all the oil and gas industry sectors, so onshore, offshore, gas processing, pipeline, liquefied natural gas, refinery, petrochemical, but we are also engaged in carbon capture, storage, utilization, hydrogen, and energy storage. Now, if we can flip the page, actually 2 pages, because I already did this, okay? I think like all of us in the industry, okay, our team at Baker Hughes has been working on how to navigate the challenges created by the COVID pandemic, okay? But I think that the dual challenge that we began tackling in the industry long time ago, okay, has not fundamentally changed. So the world will continue to demand, as you have seen before with my colleagues, more energy every day. And the world needs also energy with decarbonization, okay? So it's a dual challenge, more energy, less emission, without sacrificing, of course, the standards of safety, okay? So, and I think for all of us, we hear always the same buzzwords. So we need to focus on energy transition. We need to focus on renewables. We need to work together, which is another important element, okay? But what are the enablers? And that's what I'm trying to, let's say, show you in this presentation. What are the enablers that can make this dual challenge actually a dual opportunity? If you can flip the page, please. So I think the fundamental answer, okay, and Bob alluded to this, is technology, okay? And also I liked what Liv said in the video at the beginning. So the actual point is how to deploy technology at a faster rate. So this is actually the biggest challenge that we have. And on top, it's not only adapt, deploy, but it's also despite the economical environment that we're facing, okay? And I believe there are things, if you can flip the page, that we can do today, so not tomorrow, okay? There are several things that we can do today. So we know that natural gas can be both a transition fuel, a destination fuel. We know that oil will remain for a few years to come. And we know that decarbonization is a journey, okay? And gas will remain a key element of this journey. So the first and most important accountability that our industry, and particularly my industry, the industry of producers of equipment, is exactly to enhance the efficiency of every single component that we produce. Enhance also the efficiency of our own operations. In order to have the least possible carbon footprint as a company. So I think there are several areas, so carbon capture, utilization, storage, hydrogen, energy storage, we all mentioned it, but the critical point is going to be also scale. So how do we bring all of these new technologies, new transformational technologies to scale? Now, I will just, let's say, focus on few things on technology. I will mention that, for instance, we introduced a turbine, the LM9000. We just, let's say, successfully tested for the project in Russia. And this is going to be the most efficient turbine produced in the world with 44.3% efficiency, but also a very low emission, very low NOx emission. We are talking about 15 ppm or less. So it's an environmentally sensitive solution. So this is an example of what we can do in the industry to go in the direction of reducing the carbon footprint. The picture that you see here is actually another turbine that we have recently made. It's called Nova LT. It's a family with 12 megawatt and 16 megawatt. And what we have done here, we have used the art of high performance computational methods. So what we need to understand is the COVID is going to accelerate everything that we have at hand. So I think that COVID is going to be a very powerful accelerator of everything that we have at hand. In the past, you would do, let's say, modeling of the fluidodynamics of this turbine. Today, thanks to the fact that we can use very powerful computer machines, we actually do a point-by-point simulation, and we have been able to design this turbine in a fashion and in a way that was never done in the past. I think also something important when we think about COVID and technology. It's not just about what we can invent, but it's how fast we can bring competence in front of a problem. So one of the things that we will not be left, okay, alone in the future is the world has gone remote. no matter what we do, and we are going to do, the entire world is going remote. And this is, in my opinion, a challenge, but also an opportunity. For instance, we have been using smart helmets, okay? We have been using shared platforms. We have been using remote capabilities. So in order to do things that in the past required people, so with individual, let's say, closeness, actually far apart. So we did, for instance, this spring, in the middle of COVID, we did a remote string test at full load, full speed of the modules for Venture Global in Calcassier for Louisiana. We did this test in Massa in Italy with 30 people attending, basically not any longer in person, but attending in 5 different countries. And we did 8 hours of testing, very successful in a way that was not, let's say, possible in the past. Another important element, of course, is the development of what Bob said. So H2, CO2, and as Fabrizio pointed out, we have been mastering, in Nuova Opinione, we mastered the first compressor for 100% H2 in 1962. So we built the first 100% hydrogen-fueled turbine in 2008. So we have taken our LT12, the one that you see in the picture, we have made it let's say, suitable for 100% hydrogen today. We did test this turbine also in a fuel hybrid environment, H2 and natural gas for SNAM just in the month of July. So the technologies that are, let's say, possible today in H2, CO2 are already available. But I think what is missing today is actually the ability of us as a system to create value chains that have, I would say, system viability and actually scale. And that's where I believe what Bob was saying about the role of public institutions comes into play very, very strongly. If you flip the page, of course, there is the future with things that need to move and need to move faster. For instance, this is a compressor fully enclosed with no emission. It's a zero emission compressor. So everything stays inside this big cylinder. But at the same time, there are new technologies that are going to be fundamental, particularly for renewables. We think, for instance, about energy storage. We believe in the ability of liquid air storage, of compressed air storage. So the future is there, it's possible, but we need, let's say, innovation and technology to go together. If you flip the page, I think we have already in-house available enablers. And I see in the enablers particularly a great role in digital and let's say, artificial intelligence. I see a great role in advanced manufacturing. Today, we're doing things in manufacturing that simply 5 years ago were unimaginable, 5 years ago. Engineering, know-how and competence. So we are right now capable of doing things in engineering that were, let's say, very difficult to accomplish simply because we have more artificial intelligence. We have more ability of computational analysis. And finally, I want to bring the innovation. I believe Bob has a very important point on innovation, because innovation is not just inventing new things, is innovating also the way we look at risk. And we look at risk also in the value chain. It's easy to say we need a value chain, needs to be scale, but everyone right now has ways, parameters, has ways of coupling and with facing the industry, which are basically not an innovation mindset. They are not innovative from the point of view we tackle risk. So we need to look at the way we can take risk altogether. And if you flip the page, this is my closing remarks. I think that the areas of decarbonization, of expanding the use of new energy solutions such as hydrogen, CCUS, digital technologies, advanced manufacturing, all of these are possible, but they require a new way of working together and enabling the value chains. The new value chains need to be enabled. And the only maybe interesting point of COVID is that COVID has at the end accelerated all these processes. So the challenge is in front of us. Thank you for listening. Over to you, Liv.
Thank you very much, Michele. That was super interesting as well. And so now we will kick off the dialogue. And I think I will start with you actually, Michele, since you were last, and you mentioned that especially the role of, or how the enabler of digital development and the innovation that has happened in that space. Can you give some concrete examples of how Baker Hughes have taken that technology into use?
So what, Liv, we have many examples, and I could be talking forever about these topics.
But just short.
But I'll mention few of them. First of all, I would say 3D printing. So, and 3D printing made a big leap jump. It's not just any longer plastics. It's not any longer stainless steel. It's right now available on, let's say, high alloys. So high steel alloys. So this is something completely different from the past. And this has enabled, for instance, our ability to do new designs, because you can actually redesign a piece that is not successful, not any longer in 6 or 9 months as in the past. You can actually do it in few weeks. So you just produce something by 3D printing in a very special alloy. You test it. You don't like the results. You just go back on the drawing board. You design another one. You build another one in a few weeks. The ability, for instance, to do advanced manufacturing. So it's to use, for instance, powders. So it's not just 3D printing, but to use powders in a different way. Today we can, for instance, produce pieces just from powder and lasers. The ability to use artificial intelligence in our world. So today we monitor 1,500 equipment worldwide, simply from Florence, Houston, and KL simultaneously. So there are many things that are actually allowing the industry to do things faster. So also the design of anything that we want to invent in the hydrogen, in the CO2, in the CCUS, is going to be faster. If we think that, for instance, we have reduced the waste material of 70 to 80%. So some of the key components that we make are produced just not wasting any longer that amount of metal. We do cycles that are 50% shorter. So these are, let's say, clear example. The last one I want to mention, which is funny, okay, we can weld from a distance. So you can actually weld from with your joystick, okay. And we tested the welding with the operator in Florence, and our welding piece is actually in mass at 100 kilometers away.
Yeah, wow, yeah, that's interesting. So really contributing more to the efficiency side.
Yes.
So Bob, having listened now to these presentations where the strategic priorities are centered around, of course, more natural gas, more LNG, it's about hydrogen, it's about carbon capture and storage, it's about energy efficiency, value chain, and I mean, it comes across from both Fabrizio and Michele. I think that these technologies are mature and they are there. So when listening to them, in your opinion, what will need to happen for these companies to succeed in their fulfilling their strategies?
Yeah, so those technologies are mature, but I think we're going to need innovations and new technology to grow those up to the kind of scale and price point we need going forward. So, for example, on the CCUS side, I think it's very positive, as they both pointed out. We have a substantial global CO2 infrastructure now, right? We don't have a sufficient global CO2 infrastructure for minus 10 gigatons a year, or that we saw we will likely need. As developing countries grow their energy use and they need to go negative in their system, there's very little infrastructure there of any kind. So what are the ways to go in to new areas and provide the kinds of capture capabilities and sequestration or end use capabilities that are needed? How are those maybe cheaper? How are they easier to deploy on a local level? And how do they match up with regional differences? We talked about resources, but there are also regional differences in what's societally acceptable. So what do you have social license to do? And how can we address that? On the CCUS side, I gave some examples of new CCUS technology. I think the direct air capture, direct ocean capture areas are areas that we're just getting started in, right? I mean, there are some demonstration plants, some built and some under development. But I think new ideas there. To me, the encouraging part about those, the ones that are there now, is that it shows that we finally, are starting to take this seriously and are hitting stride in putting a lot of our creativity to bear, bringing that to bear on how we address a problem like CCUS. I think that one's been put in the background for too long. People would like not to do that, but we don't get there without it. So things like this electro swing absorption for carbon capture is a really interesting technology, which instead of the high energy penalty of an amine absorption process, where you have to use some of the energy from your process for the desorption step in the desorber. Instead of that, you design a swing process, of electro swing process, let's call it, in which you flip voltage. So depending on the voltage, about a 0.9 volt change in voltage between where you absorb CO2 onto an electrode surface versus a voltage which you desorb. And you can have one train running. It looks like a lot like a battery, actually. You have one train running, which is absorbing CO2. The other train is running in a desorption mode. And very inexpensively flip in voltage and you reverse that around. And so I don't know if that's where we'll end up, but I think it's an example of really creative new thinking in how to do this. And of course, that idea is great, but it has to be scaled up to this, minus 10 gigatons a year scale, that and some allied technologies.
Yeah. And we often look back to the development of renewables technologies. We're actually starting to use them and build these plants and facilities, took the cost down. And maybe this is what we need to see on the CCUS side as well.
Absolutely.
Yeah, Fabrizio, I have a question for you because you talked about the balance in the energy system and that we need the fossil fuels to kind of balance. We need still investments in oil and gas to balance, make sure we have the balancing for the energy system. But what about battery storage? Is that something that you have been looked into as a strategic option?
Yeah, of course. I mean, now the situation is such that for EPC contractor, which we have a role of integrators, because we are integrating technology, we are designing processes all together, putting the best technologies all together to make something that is working properly. For sure, the battery storage is something that we are looking at. We are looking at different options of storage, air storage, air compressed storage. We are looking at the traditional storage. This is something which is, in any case, more related to manufacturers than EPC contractor. But as EPC contractor, we are identifying the way to bring it into the current value proposition of our traditional clients. So I think that one of the most important, let's say, things that we have to take into consideration in this period of time is the fact that basically we have in the oil and gas industries clients that are going into a specific direction. It's pretty clear where BP, Shell, Eni, Total wants to go. Everybody is declaring a net zero ambition. As EPC contractor, what we can do? As EPC contractor, as what we are doing, for example, in the battery storage, but many technologies like that, we can support them in the path of transition. How we can support them in the path of transition? As EPC contractor, first of all, we have to change the way we approach in terms of commercial strategy our clients. We must shift from push to pull. We have to identify new solutions. So if we believe battery storage, air compressor storage, and whatever can be the right solution, we can put it in place. We have to find the right way to create a process, an engineering process that it works. And to do that, we have to push this kind of solution with our client. The problem I see now, it's very simple. In my opinion, even if there could be the need of scale, for sure, at manufacturing side, we have to give something more reliable, for example, for the CCOS. We are working on that with the technology that we acquired, because we are working to, let's say, to deploy this technology for higher sites. But in any case, I'm very positive on technology side. I think that we have everything on our hands to create this kind of environment. What is missing now, I fully agree with Michele, is the way we integrate those technologies to create a business model. Now the industry needs a real business model. Each part of the industry has to know what is the role, which kind of return they can have, and how we can integrate ourselves as a single supply chain in order to make it happen. So the need of a business model, it's something which is really important for the entire industry, and we have to do it together. Why I'm saying that? Because our vision as Saipem, we do not see a sort of dualism between green energy and gray energies. What we see is not a world where there is the green against the gray. What we see is a full integration. What we see is hybridization. We see a world where we can take the best of both worlds, green and gray. And to do that, we need a business model.
And I think you have all mentioned the value chains and the business models and the strengths in partnering in the industry. But can we really, is it really enough that it is the industry that take care of this? Is it too much to expect of the industry, or do also governments need to come along?
For sure, the role of governments, as I said before, is crucial, and we need to speed up it, because the time that we have from an industrial point of view is totally different than the time the government are used to have. So we need to work on it. But as industrial part of the game, we have a crucial role as well, because we are the ones that knows the technology. We are the knowledge owners. We have the possibility to show what is the path, but some path which is really, in a way, workable. It should be practicable, because we can talk about CO2, we can talk about hydrogen, but we have to integrate all of it into something which is workable and something that could work. But the industry is ready. So each piece of the supply chain is ready. Baker Hughes with its own valves, supplier of other equipment are there, are ready to work. It's just a matter to find a way to work with an integrated business model.
Michele, you have any comments to this?
No, I wanted to add something interesting to the way you introduced the question. Because if I go back in history, you know, and we go back, I don't know, early 60s, okay? In the early 60s, there was no natural gas in Italy. So the country was basically going with a lot of bottles of propane. So the state, okay, the government, the Italian government, embarked in a huge project of methanization of the entire country. So, and the big pipelines were created. So that enabled the country to have methane everywhere. So I see us in a similar state. So if we want as a future to have all our pipelines capable of, let's say, having methane and hydrogen, for instance, blends of methane and hydrogen, that is, today it's possible. Our compressors are capable, the turbines we demonstrated are capable, they could be actually hybrids, so they can be dual fuel. The critical point is that we need infrastructure. So we need the governments, the public institutions to step in with infrastructures, policies, legislations that allow at the end the new world to have a dawn, okay?
Yeah, yes, Bob?
Could I just a few
Yes,
comments
please.
to that? So it's great that the pipeline structure exists in Italy. And I'm not sure quite what the blending ratio limit is right now in Italy. It'd be interesting to hear. But eventually we need to get to 100% hydrogen in those pipelines, but to get to the zero carbon limits that we're looking to. In the interim, of course, you can use other solutions. Italy has a lot of hydro, of course, which is very important for meeting intermittency needs, but other regions don't. Other regions can use batteries are the method of choice right now for 4 to 8 hour storage duration ranges. As we look towards a full decarbonization of the grid, you get down to 50, 10 or less grams of CO2 per kilowatt hour produced, it gets really expensive to decarbonize. And so it's not at all clear that certainly traditional batteries or batteries like lithium ion batteries, maybe flow batteries can do that. But maybe we need to go for regions that don't have massive hydro, need to go to something like hydrogen as a fuel. That means getting the price of hydrogen down lower. It is coming down fast. Steam methane reforming plus CCS is getting pretty cheap, down $2 or a little bit more per kilogram of hydrogen. So that's in the right direction. There are other storage methods we could bring to bear in the intermediate term, and I'll say it depends on where you are, but it could be out to 2050. If you have infrastructure turbines that have been used with a gas power plant, a peaker, for example, or even a combined cycle plant, you could envision, if you want to take off the natural gas feed by regulation, you could use those as thermal storage units, right? So you could replace the gas feed or coal if it's a coal-fired power plant with a storage tank, use molten salt or something like that in a single thermocline tank, use joule heating, so electrical resistance heating to heat the salt when you have cheap excess solar or wind. And then when you need power, you use that heat source to drive the turbine, right? And that reuses existing infrastructure for decades to come, whatever the lifetime of that turbine is, which could be a really useful way to take advantage of sunk investment in that infrastructure, allow you a zero carbon storage technology, which can have long duration, and provide that storage already hooked up to the grid because your gas power plant was already hooked up to the grid. So there's a lot of work going on things like that, innovations like that. I think could help us bridge our way into 2050 and beyond.
Let me take us back to what you started with, and that was the price of carbon, Bob. Very high prices in order to achieve the negative emissions that we need by the end of the century. But if we look at the carbon price we need in order to kind of enable the uptake of CCS technology, what what carbon price would kind of be the right level for CCS to be scaled? The reason I ask is that in our study, we see that the uptake of CCS doesn't really pick pace before like 2040, so a bit late. And because it's only there that we see that the carbon price starts, you know, coming to that level. But what can we do in order to make that come earlier?
So good point. And a challenge fundamentally with CCS is that it will always be cheaper to emit the CO2 than it is to capture it and do anything with it, right? So early adoption has focused on what value can you find for the CO2, and the only at scale use of CO2 I know of, I mean large use, is EOR right now, and I think that's what's funded the CO2 infrastructure that exists in parts of the world, and that's been very helpful for EOR. In the U.S., I don't know policies around the world. In the U.S., there's a part of the tax code called 45Q, which provides a tax incentive for CCS. If you capture CO2 and you use it for EOR, there's a $35 a ton tax credit. If you use it or sequester it, and that could be either put it in the ground in a storage reservoir, or you use it to make materials where it's sequestered for long periods of time. Either one of those, you get $50 a ton. And that has, I think, helped to incentivize companies to go ahead and start to build significant sized demonstration plants. But you know, you don't have to look further than, say, the Petronova plant that's temporarily shut down. There's just not quite the economic proposition you want to make CCS work. I mean, interesting observation is that you could, of course, with the sequestration part, if you're going to use CO2 for EOR, for flooding, you could conduct the flooding operation in a way that leaves more CO2 behind, enough more behind, so that it's actually carbon negative, right? But that's not economic, since you have to pay to get the CO2 right now, right? And so incentives via a higher price on CO2 would allow, I think, allow the industry to start expanding that at the kind of, if we're going to be ready for -10 by 2040, 2050, 2060, we need to scale up now.
Yeah. Any comments from the rest of the panel on the
Yeah, I would. That's something which is really important for the evaluation of the cost for the carbon capture. I think it strongly depends on, let's say, the specific project we're talking about. So the overall structure of a CCUS project includes a capture, includes transportation, includes storage. The storage can be very far from the place where the CO2 is first captured and then initially stored. So there are possibilities to use existing infrastructures, and in this way you can save a lot of money. So in my opinion, this kind of range, I fully agree with Bob with the numbers given in terms of range from 30 to 50 to 60. It strongly depends case by case about the availability of existing infrastructures. The two main points on CCUS are, first, the transportation, and second, the availability of a safe storage place. If it is available, and it's also available the possibility to have the transportation lines offshore or onshore to arrive there with the facility to compress and to store the CO2, it's totally a different, let's say, equation for the cost of the CO2. Otherwise, if you have to build the entire value chain for the CCUS system, then this is something that, in my opinion, with the price that we have for the CO2 now, in the market is not enough, and there is the need for incentive, either via, I would say, carbon tax, or really incentive to capture the CO2.
Michele, you want to comment?
Eva, I just want to say that right now, the way the value chains of CCUS are structured are going to be very geographical. We'll have the only places where, and Ravenna is one of them, it's a great example, the only places where you can combine emission, and you can combine emission with storage availability. So those are the right places. So CCUS will not be broad and spread as we think. It's going to be very geographically located. So one of the things I believe where the university can help is to imagine a different utilization. So whether that could be, let's say, combining the CO2 with something else, producing something else, not just, let's say, sequestering and putting back into the ground. So it needs to be something, another, let's say, other chemical bonds, okay, for the CO2, and produce new value chains. Otherwise, the CCUS by itself is going to be geographically confined.
Interesting perspective.
I mean, so a challenge with the use is finding uses that are at the scale that we're talking about here, this 10 gigatons a year. The kind of material that I think of when I think of scale you want is concrete. If you can get something at that scale, then you're making a real material difference. But that's turned out to be a really hard problem, is to find ways to reinforce concrete that use up some of that CO2. I mean, I know there's some research going on looking at, for example, not capturing CO2 in a traditional way, but pyrolyzing natural gas, so very high temperature pyrolization. So you get hydrogen and carbon out. And then the carbon you can use, at least there's work looking at how you could use that as a concrete or a polymer reinforcement as a concrete replacement. And could you replace concrete at a global scale? And that could be interesting, but that's I think early stage work.
I know, I'm aware of some of that research, very interesting. Yeah. You know, time is really flying, and we really covered, I mean, it's super interesting discussion, but we only covered parts of the issues here. And one thing that I'm personally very curious is one technology you brought up, Bob, and that is fusion. How far away is that?
Well, closer than you think.
Is it?
Well, I should find out what you think first. But
so I mean, in our report, it doesn't really come into play due to the high cost, so it's not really visible in the energy system by 2050.
So there's substantial uncertainty on the cost once we get it, right? But you know, the startup that came out of MIT, Commonwealth Fusion System, is looking at a steady state demonstration power plant in early 2030s, 2033, I'll say, right? So something on that order. That would be a first one, right? So you wouldn't expect it to have achieved the economies of scale that you get out of the natural gas power plants, where we have a lot of experience and a lot of, as Michele showed, a lot of very detailed engineering experience in how to build those. So I don't know. I've seen estimates of $50 to $70 a megawatt hour, which is pretty good, given that there's no emissions from that and no radioactive waste problem to deal with. So if that's available, right, as we think, then I think that could have a huge impact going forward. And like I said, there are these 20-something different approaches, but I think all of those startups have fairly short time horizons that they're looking at. One interesting feature of those is those are thermal processes, right? And so you can do combined heat and power and do some coupling with industry that you can't do with some other zero carbon technologies.
So very interesting, and absolutely a space to watch. In the meantime, actually, I'm very encouraged to see the strategic priorities of companies such as Baker Hughes and Saipem, because I think that's really what will drive us quicker through the energy transition now in the shorter run. So unless you have any final comments, any of the panelists, I will round it off. But I give you the opportunity first to say something if you have something that you really need to say.
As a former nuclear engineer, I'm very interested in fusion.
Yeah, exactly.
and I'll just say that I've enjoyed this immensely, and I think this idea of partnerships and finding coalitions you can bring together with different skill bases and different technologies and different points of view, I think that's critical for us to get to where we want to go. So I really enjoyed this. Thank you.
Okay, thank you very much to Fabrizio and Michele as well, and to Bob.
Yeah.
I hope
Thank
you
you.
enjoyed it.
Thank you. Thank you, everybody.
Thank you.
Bye.
Bye.
Are you still there?
I am still here.